It is recording. So it turns out that it's only you and me today, and Pranit is not available. Uh, so I just wanted to go over 5-pack differential pair design and analysis. Okay, it is not as straightforward as textbooks make it seem. So at least I'll try and approach it through first principles and make sure we design a very basic. Very basic single stage 5-pack differential pair, all right?
Yes, okay.
Fair enough.
So yeah, just before that, you had given me a thing to solve the last time.
Okay.
So out of that question, I just want to like make sure if I'm approaching it correctly or not.
Okay, I don't remember the question, to be honest.
Yeah, so that was like the minimum and maximum VCM for the circuit you showed. Yeah, this one.
Of this
Uh,
circuit.
yeah. So VCM,
Okay,
how
great.
much like yeah, the swing limit, how much can be of VCM?
Hmm.
So I mean, maximum that I'm getting is 2.799, but minimum is gonna depend on the V bias of the current this current mirror. Is that okay?
Beautiful. You are right. So it depends on what? The VGS minus VTH of this fellow, right?
Yes.
Of this fellow. So let's call that delta V, VGS minus VTH of this device. So VCM min will be VGS required to keep I naught plus delta V. Fair enough?
Yes.
VCM max is what?
PCM max that I'm getting, that is
No. Don't tell
VDD.
me
Okay.
value. So this
Okay.
will be 2.5 minus VSG. Fair enough?
Yes.
So V max can be 2.5 minus VSG plus VTH. Correct?
Yes.
In other words, just replace this with VDD minus VSG plus VTH is the maximum voltage here. Fair enough?
Yes, exactly.
Awesome. Great.
Uh,
No, if that is solved, any other doubts?
no, that was it. I mean, I thought
Awesome.
like just to ask in case if I'm going
Yeah.
right.
That's awesome. Thank you. Have you been solving assignment questions?
Yes, I do them.
Okay. Any questions in those?
As of now, none. I mean, I'm trying. There are a few questions that are left, but I'm just approaching them. Like more than half I have solved.
Fair enough.
A few
Great.
are left.
So today I want to discuss 5-pack differential pair. Okay. Then talk a bit about negative resistors and what do they even mean? Okay. That is the intent of today's talk. Fair enough.
Yes.
Awesome. So, okay, let us. I mean, I am sure you know the generic 5-pack differential pairs circuit diagram, right?
I'm not sure.
Okay. The generic differential pair. Okay. Let us say I want a circuit. We till now we discussed fully differential amplifiers, correct?
Yes.
So it basically looks like this. Fair enough.
Yes.
But in some special cases, not in some special cases, but you also need op amp which reacts, which is a differential input but single-ended output. Fair enough.
Yes.
You need such kind of op amps, right? In
Yeah. I
reality,
mean, mostly. Yeah. Mostly we
mostly.
see them only. Yes.
I wouldn't say mostly, but anyway, we do need them. It's
Okay.
very important class of op amps. Fair enough.
Right. Yeah.
Yeah. So, did we learn how to make this?
I haven't gone through that lecture, or I mean, we didn't discuss it
No. It's okay.
previously.
The question is you don't know, right?
Yes. I don't know.
Awesome. So it. But what do you know? You know how to make a circuit
Yes.
which reacts to a differential input. Yeah. So a circuit which reacts to the differential input and not to the common mode output. Correct?
Yes.
Is this one of those circuits?
Yes, I mean it reacts least with to the common mode, but
Yeah, I mean
maximum with the
least being the
differential mode.
keyword. Okay, how do you make it ideal? Let's say I don't want it to react only.
Okay, so in that case, so this I naught has to be well controlled, and the parameters of both the sides have to be like uh, very stringent, like almost equal.
Oi, don't give me a generic answer, no. Give me mathematical. Both sides should be symmetric.
Yes, yes, symmetric.
Okay, so this is easy to do. Correct in layout, make one side, copy paste on the left side. Fair enough?
Yes,
This is easy, right?
yes.
But what is difficult?
The current, the current
Okay,
source.
what is the property of this current source which makes this circuit not react to VCM at all?
So at its node potential, which is like the source potential of both the this thing, so uh, it doesn't react to any signal. I mean, uh,
In
so
electronics
all
terms?
uh, electronics terms. So that should be fixed. A fixed bias should be there.
Okay, in again, I'd force you to give me a better answer. Okay, what is the common mode equivalent of this circuit?
So that 2I naught will be, I mean, we can divide it half if we do the half circuit. So it will be
Okay,
divided into I naught.
okay, fair enough.
Then we have the let's say left hand side the transistor and the circuit on top.
Fair enough.
Yes.
Now, if I give a common mode signal, what is the gain here?
So V naught, okay, we the I naught, if we see over here, then we need to have it will act as a resistor. So the resistor has to be very perfect, like R naught has to,
R naught has to be
like, so it
very
has to
high
be very
or
large,
very large.
very large. Yes.
So, if I have one transistor, what is the R naught? I mean, R naught will be R naught, right?
Yes, yes.
How do I make this better?
I mean, we can use another transistor below this one to
What is
make
the
it like uh,
cas?
cascode.
Perfect, very nice. So VB1, VB2, fair enough.
Yes.
Now, what is the looking down impedance?
Approximately it will be GMEB2 into R naught 2 square if both are equal.
Correct, right?
Yes.
Great. Now, okay. Now you made the common mode very strong. Correct?
Yes.
I mean the gain of common mode is very weak.
Yes.
Now, what did you give away?
So the area was one thing we had to.
Okay, let's forget about area.
Okay.
You
So
know this.
now, uh,
What is the
the
common
swing,
mode maximum swing?
swing. Yeah, swing is what
Correct,
we.
right? Now, what
Yes.
is the minimum potential here?
That would be VGS.
No. Yaar, see, if there were only one transistor, if I connected VB1 here, what is the
Oh,
V
VB1.
plus swing?
That would be VB1 minus VTH.
Beautiful. Now, what is it? For if I have this fellow, cascode.
So in cascode,
No. Let's say I have this circuit.
yes,
What is VCM minimum?
mm, we did it. We see that was VB1. Mm,
No, will this get crushed first or this get crushed first when this potential keeps reducing?
so if this keeps reducing, then
Hmm. Okay, what is this potential, Ravi?
you mean like that will be VB1 minus VTH at
Yeah,
least.
VB2 minus this potential.
Or in terms of VB2, if you're talking.
Hey, it will be in terms of VB2 only, no? If I connect a VB2 voltage source here.
Yeah, okay, I was looking from downwards like VB1.
No,
So
okay,
if you
this
look to
potential is set by this fellow or this
wait,
fellow? This potential is
uh,
set by this fellow or this fellow?
uh, I'm not sure in that case. I mean, it should be both the VB1 and VB2 should be setting that, right?
Oh, okay. Let us forget about the Uberka circuit.
Hmm.
Okay.
Right.
Let's say you have some VB here.
Yes.
What sets this voltage?
Or the current in this case.
The current, I mean, no, right? The current source is just a current source. It will push current whatever this voltage is here.
Okay, so VB1 minus VT will be the minimum voltage that
Huh.
will be present at the
Yeah.
drain.
So in this circuit, the voltage is undefined. If it has to be set by some external guy, correct?
Yes.
In the sense, okay, what I mean to say is if lambda is not equal to 0 or lambda is equal to 0, there are two cases, correct?
Yes.
Before we talk about all complicated circuits, this is a very simple circuit, correct?
Yes.
We should definitely understand who sets this voltage,
Yes. Yes.
correct? Okay, let's say lambda is not equal to 0 and I call this VD. What happens?
So there will be some potential at VD,
Correct.
which yes,
So ID
and
is
ID is K half mu on COX W by L into VB minus VTH square 1 plus lambda VD.
into 1 plus lambda VD. Fair enough?
Yes.
Now, is anything unknown? ID is known.
Yes, ID is known.
This is
Let's say the
known. This is
process
known.
known.
VD
VD
is the only
term which is unknown.
unknown. Can you find out?
I mean, in this
I
equation,
mean,
yes.
in this case, you can find out, right?
Yes, just one variable.
No.
Yes.
Let's say this gives you a VD, which so turns out that VD is less than VB minus VTH. When you do this calculation, VD can be less than VB minus VTH or VD can be greater than VB minus VTH, correct?
Yes.
If this is the case, you have no problem, correct?
Right.
If this is the case, what will you do? If this is the case, definitely you use the wrong equation, correct?
Yes, I mean, in that case, it is wrong.
So what do you do?
I think either we might need to, so because this is less than VB minus VTH, VTH is fixed, we might reduce VB, but that would again impact the current.
VB is fixed, yaar. The question is, what is the value of VD?
So if we get this one,
that means
so we try to increase the R naught because it's a resistance across which the current is falling, right? So that will increase the potential.
No. Yeah, there is no R naught. There is only this circuit. This is the circuit. Okay. Someone has connected this circuit and they're asking you what VD is. They're not giving you any resistor. You're only analyzing.
So we'll increase, I mean, can we increase ID?
No, you can't. Someone is connected the circuit.
Okay, I mean, what will we do? We can't do anything then in that
No,
case.
no, you can, right? I mean, what you should try what? You should try using triode equation, correct? See, this
Okay, so that would
transistor
be
can only be in either triode region or saturation region.
saturation. Yes,
So you tried the saturation region equation, it didn't work.
right, okay.
You will put the triode equation and solve for VD.
Right.
Even in that equation, your only VDS is unknown, correct?
Yes.
So the device will either be in triode or saturation. There is no other mode of operation.
Yeah.
Fair enough?
Correct. Yes.
Great. So now that this basic is given to you, now help me make this. Help me understand this circuit. Fair enough?
Right.
Now this is some VB. Fair enough? Now what is this potential?
VB minus VGS in this case, but
Okay. And VB minus VGS of this transistor so that I naught will flow.
yes.
Okay. So in this case, this potential is set by this potential.
Right. Yes.
Fair enough?
Yes.
No. In this circuit, what is this potential?
That will be VB2 minus VGS.
Perfect. Thank you. And what is limiting? Okay, if let's say you connect VCM here and VCM here. What is the VCM min?
VCM min in this case would be so that should be VCM. So for that we need VD, right? Of the
what sets this VD of the bottom transistor?
So VB2 is setting it.
This potential.
So that will be VCM. So okay, VCM min minus VGS.
Thank you. VCM min minus VGS should be greater than
VT.
This is drain potential of this transistor. VD should be greater than.
But this is okay. So that should be greater than VB2 minus VTH.
Fair enough? No, what is the constraint on VB2?
Constraint on VB2.
How to keep this transistor in saturation?
So VB2 minus VGS should be greater than VB1 minus VTH.
Fair enough?
Yes.
So what is VCM min?
So VCM min would be that
VGS
should be greater than
this
VGS.
transistor.
Yes, and VGS of that transistor plus VB1 minus VTH. Minus VTH.
Think.
So
what is the condition of VB2 should be greater than VGS plus VB1 minus VTH, correct?
Yes, that's true.
So this I plop it here, correct?
Yes, we plotted. So VGS plus VB1 minus 2 VTH.
Okay, sorry. Thank you. So VCM min is greater than what? 2 VGS plus VB1 minus 2 VTH.
2 VT.
VB1 is also VGS, correct? Approximately.
Yes.
So this is basically 3 VGS minus VTH minus 2 VTH. Or in other terms, VCM min should be greater than. Can I write this as delta V plus VTH?
Delta V plus VTH.
VGS,
Yes, yes, yes.
VOV plus
Anything above
VTH,
that.
correct?
Yes, yes,
So
that
it
is.
becomes 3 VOV plus VTH.
Yes, exactly.
Now, what if it were one transistor? What would have been VCM in?
That would be VB2 minus VTH or VGS minus VTH.
So delta V only.
Yes, exactly.
So what did you lose?
Oh, okay, the swing. I mean, here the minimum is more than the previous one.
Huh,
A lot more than the
a
previous
lot
one.
more than the previous one.
Yes.
Fair enough.
Yes.
To make a so you understood the trade-off, right? To make a good common mode rejection, you will be limited by swing. Fair enough. You understood the trade-off, right?
Yes, yes.
High CMRR implies
Low swing.
low swing. So this is the trade-off you have to play with. Fair enough?
Yes.
Okay, great. I think I went on a huge tangent, man. Correct?
Yeah.
Oh, I think.
Sorry, I mean, like it's just the basics that I mean.
Yeah,
need
you
to be
should
very.
know. You should know. It's good that you know. Okay. Now I will pull you back to the same discussion. I wanted what? I wanted this op amp. Fair enough?
Yes.
I want the output to be. Sorry. V out needs to be A times V plus minus V minus. Correct?
Yes.
So you know this circuit. You know this circuit, correct?
Yeah, I mean in this, yes. That is V, but that is like V out plus and V out minus.
So V out plus. So I can write V plus, V minus, VO plus, and VO minus. Fair enough?
Yes.
Now, can you help me make this from this? What is the dumbest solution?
Connect a register in between. Like may make so the dumbest would be like, oh, we cannot force one to ground, right?
I mean, the world is your playground. Try it out.
I mean, one of the would be like we keep a resistor in between them, but that would again be V naught plus.
Ravi, so let us stand back. What is the gain here? Minus GM R times V plus, correct?
Yes.
And what is this?
So minus GM R times V negative.
Fair enough?
Yes.
It is actually, I mean, it's a differential circuit. So if I call this plus VD, this will be minus VD, correct? And this will be G minus GMR VD and plus GMR VD.
Right.
If I take this guy, this one guy, don't I get this operation? I can only choose one arm, right? As the
just one of them.
Yeah. That is the dumbest solution, right? I won't even use this.
Yes, I mean we can just have one out of two. But so I just like if I say that like how is it in terms, so it is in terms of either difference of the output upon difference of the input or single output by single input, even if we like
What
put
is
it
this
in.
here? See, all I want is V out should be A times VD, correct?
Yes, that is what we. Okay, fine. Yeah, in this case, yeah, that's fine.
So if the dumbest solution is to just take this guy and tell you it is the output, correct?
Yes, exactly.
That is the dumbest solution. Fair enough?
Yes.
But you definitely know it can be improved. Or do you think we can make it better?
We can try to. So
Hmm. So what are okay? So let us start here. Let us start here. I mean, every engineer starts from somewhere, correct?
yes.
So let us start here. So is this current doing anything here? I mean, if I'm not taking the output of the resistor, I might as well connect it to supply, right?
Directly.
Correct? What is that? This resistor wasn't doing anything for me. I mean, this was just making sure that this transistor is in saturation, correct?
Yes.
If I just directly connect also, it will continue to be in stronger saturation than before, correct?
Yes. I mean, in that case, yes, definitely.
Correct, right?
Yes. Yes. I mean,
Okay.
because
Now, let's say this was, let us replace this with an ideal current source for now. We'll deal with common mode later, okay? And I'll call this
right.
2i0. If I connect VCM and VCM here, right? The
Hmm.
gate source potential of both transistors is the same, so current has to be I0 in both branches, correct?
Yes.
You agree, right?
So, I mean, if there is a non-ideality of R naught, like lambda present in both
No,
of
no, no,
them.
no. Let us put lambda equal to 0 for now.
Okay.
Let
Yeah.
us
In
not
that case,
complicate
yes.
our lives with lambda now. Fair enough?
Right. Yes.
Okay. So both are I0, correct?
Yes.
No, this circuit is the same as this circuit, correct?
Yes. In this case, yes.
So what would I mean? Okay, let's say I want to increase the gain of this fellow. What would I do?
Um. So, I mean, we have like GM, R, and VD. So we can increase GM. We can increase R.
Okay, these are all generic ideas. What is a more intelligent idea? If this R wasn't there,
Right. So this would be in the stronger saturation as well.
but you need this current, but you need an open circuit also in differential. I mean, in small signal model, correct?
Open circuit.
Yeah, this for this GM, what is limiting the gain? This fellow, right? GM into R.
Yes, R is limiting it. Yes.
R is limiting it. So if you had an open circuit in small signal sense,
Right. Yeah.
then the gain would have been infinite.
Yeah. So, I mean, you mean ideally like this R, basically, if we can increase it a lot instead of this, like something like infinity.
So what component is small signal open, but at DC it gives a current.
I mean, in terms of transistor or?
No, ideal component.
Okay. So that is an inductor.
In other words, a current source, correct?
Yeah, I mean even current source also.
Yeah, current inductor is a good idea by the way, but we can't do inductors on chip, correct?
Yeah.
So I can put a current source.
Yes,
And
DC it will be open.
What is the
yes.
current of this current source? I0, correct?
Yes.
Because I know I0 has to flow here.
Right.
So how do I generate this I0?
I0. So a current mirror or something.
Exactly, right?
Yes.
So there will be a current mirror here. This guy will share the current mirror. If this is 2W, this will you will call it W, correct?
Yes.
And then push it on a PMOS. And then push it down. Fair enough?
Yes.
and
and
you
you
will
will
okay,
okay.
fair enough.
Fair enough.
Yes, yes.
If this
If
is
this is
2W, this
2W,
will
this
be
will be
W,
W,
this
this
will
will
carry
carry
I
I
current,
current,
this will
this
be
will
I
be I
current.
current.
Fair enough?
Fair enough?
Yes, yes.
No.
No.
Do you
Do you
think there is
think
an
there is an
optimization
optimization
still?
still?
Uh, I mean, what about, is it changing something about swing or something?
No,
No,
no.
no.
What
What
current is
current is
being
being
wasted
wasted
in this
in this
circuit?
circuit?
Current, I not,
Is
Is
this
this
doing
doing
anything?
anything?
nothing.
No,
No,
right?
right?
This is
This is
only
only
present
present
to
to
give
give
common mode
common mode
rejection.
rejection.
I
I
mean, I
mean, I
need
need
two
two
inputs,
inputs,
V
V
plus
plus
and V
and V
minus,
minus,
and I
and I
want
want
common mode
common mode
rejection.
rejection.
Only
Only
because
Yes,
of
because
that
of that
reason,
reason,
this
this
whole
whole
branch is
branch is
there,
there.
correct?
Correct?
yes,
And I
And
know
I
the
know the
current on
current
it
on
is
it
I
is I
naught
naught
yes.
because
because
this
this
VGS
VGS
is
is
same.
same.
Yes, yes.
So
So
what can
what
I
can I
do?
do?
Can we just force a current I not there?
We
Or
can
We can
use
use
this
this
current to
current to
generate the
generate the
VGS
VGS
and
and
not
not
go
go
all the
all
way
the way
like
like
this.
this.
right, right.
Uh,
Okay.
uh, if I
If I
redraw the
redraw the
circuit,
circuit,
cut this
cut this
fellow,
fellow.
and
And
so
so,
okay,
okay,
okay.
okay.
Let me
Let me
not
not
erase.
erase.
Let me
Let me
rewrite.
rewrite.
So
So,
fair
fair
enough.
enough?
Yes. So basically, like, why generate, why have extra circuitry or unnecessary wastage? I
Yes,
mean,
Yes,
sir.
sir.
in all terms.
Yes, sir.
Yes, sir.
You
You
see it,
see it,
right?
right?
Yes,
So
yes,
there
So
is
yes.
there
no
is no
Makes
unnecessary
sense.
unnecessary
circuit. There
circuit.
is
There is
no
no
nothing.
nothing.
This
This
circuit
circuit
will
will
ensure
ensure
you
you
have
have
very
very
high
high
gain
gain
here,
here,
right?
right?
Because if
Because if
lambda is
lambda is
zero,
zero,
right,
right?
there is
There is
nothing that
nothing
is
that is
limiting this
limiting this
circuit to
circuit to
give you
give you
infinite
infinite
gain,
gain,
correct?
correct?
Yes.
Because this
Because
is
this
a
is a
current
current
source.
source.
Okay,
Okay,
this is
this
a
Yes,
is a
current
current
yes.
source,
source,
Right.
correct?
correct?
Yes,
And
correct.
you
And
know
you know
this is
this
I
is I
naught
naught
because
because
this is
this
I
is I
naught.
naught.
I
I
mean, the
mean, the
VGS
VGS
of
of
these two
these two
fellows are the
fellows are
same.
the same.
And hence
And hence
equal
equal
current should
current
flow,
should
hence
flow,
I
hence
naught
I
I
naught
naught
I
will
naught will
flow,
flow,
correct?
correct?
And
And
this
Yes.
this
gate
gate
potential is
potential is
generated
generated
like
like
this
this
using this
using this
diode
diode
connected
connected
MOSFET.
MOSFET.
Fair
Fair
enough?
enough?
Yes, yes.
Great.
Great.
So
So
we
we
definitely
definitely
made
made
one
one
thing.
thing.
We
We
know that
know that
we
we
know
know
differential
differential
gain
gain
is
is
very
very
high
high
for
for
this
this
circuit
circuit
when
when
compared to
compared to
this
this
circuit,
circuit.
correct? I
Correct?
mean,
I
when
mean,
compared to
when
this
compared
fellow
to
and
this
using
fellow and
only one
using
amp,
only
which
one
was a
amp, which
dumb
was a
idea to
dumb
start
idea to
with,
start
correct?
with. Correct?
Yes.
Now we have
Now
a
we
we
have a
potentially better circuit.
we potentially better circuit.
Fair enough?
Fair enough?
Yes. Yes, agree.
Okay.
Okay.
But
But
do you think the
do
circuit
you
is
think the
symmetric?
circuit is symmetric?
Um, I mean, I don't think so.
Hey,
Hey,
it's either yes
it's
or no,
either
man.
yes.
What is don't think so?
No. I mean, I would say no.
It's not symmetric,
Uh,
right?
I mean, in terms
It's
of
not
current,
symmetric,
yes.
right?
No,
Yeah,
no.
in terms of
In
current,
terms
yes,
of,
but
okay, to do
otherwise,
half
In
no.
circuit
terms of, okay,
analysis,
to
can I
do
do
half
half
circuit
circuit
analysis, can I do?
analysis?
No, we cannot apply in
No,
this.
right? Definitely not. Now, have you seen this circuit before? Hello? Hello? Hello, guys, can you hear me?
Sangamitra, can you hear me?
Yes, sir.
Awesome.
Awesome.
Ravi, can you hear
Ravi,
me?
can you hear me?
Yes, I can.
Oh,
Oh,
was I cut off?
was I cut off?
I don't know. Seems so. We could see you, but no, the
Anyway, it's
presentation
okay.
Anyway,
got
it's
froze.
It is
okay.
what it
It
is.
is what it is.
So, where were
So,
we?
where were we?
Huh.
Huh.
So, we know
So, we
that.
know
Okay,
that, okay,
first of all,
first
did
of
you
all, did you
understand the
understand the
derivation of this
derivation of
circuit,
this circuit,
Ravi?
Ravi?
Yes, yes,
You understood
You
the
understood the
derivation, right?
derivation, right?
yes.
And
And
you know
you
that
know
this
that this
transistor is
transistor
just
is just
another
another
transistor here,
transistor here,
like this.
like this.
Fair enough?
Fair enough?
Yes.
So, how
So, how
many
many
transistors do
transistors
you
do you
see?
see?
5.
So, this
So,
is
this is
called a
called a
5-pack
five-pack
differential
differential
pair.
pair.
Oh, okay.
This
This
is
is
extremely
extremely
used.
used.
In
In
fact,
fact,
I'd
I'd
say
say
abuse
abuse
circuit
circuit
in
in
analog
analog
electronics.
electronics.
So
So
we
we
need to
need to
understand how
understand how
this
this
works.
works.
Okay,
Okay.
Yeah, right, right.
fair
Fair
enough.
enough?
So that current is the main thing, like, and utilization of the full circuitry.
Exactly.
Exactly.
Not
Not
wasting
wasting
any
any
bit of
bit of
current.
current.
Yes.
So,
So,
but
but
I
I
explained
explained
everything
everything
in
in
DC
DC
analysis,
analysis,
correct?
correct?
Yes.
But
But
we
we
should do
should do
small
small
signal
signal
analysis and
analysis and
find out
find
what
out
is
what
the
is the
small
small
signal
signal
model of
model
the
of the
circuit
circuit.
Right.
when a
When a
differential
differential
input is
input is
given.
given.
We know
We know
what
what
happens
happens
when
when
VCM is
VCM is
given.
given.
Now
Now
let us
let us
give a
give a
plus
plus
VD and
VD
a
and a
minus
minus
VD.
VD.
Fair
Fair
enough?
enough?
Right.
And
And
what do you
do you
expect
expect
here?
here?
Some high
High
value
value
times
times
VD.
VD.
Yes.
Correct?
Correct?
We will know, we
We
will
will
let
let
us
us
see
see
what
what
this
this
value
value
is.
is.
Correct?
Correct?
Yes.
And
And
let us
let us
continue
continue
to
to
let us
let us
continue
continue
to
to
okay,
okay,
I
I
think I
think I
should
should
also
also
huh.
huh.
So
So
I'll
I'll
go
go
for a
for a
small
small
detour
detour
and
and
come
come
back.
back.
Okay.
Okay.
Sure.
So do
Do
you
you
know
know
short
short
circuit
circuit
current
current
and
and
R
R
out
out
method to
method to
find
find
out
out
gain?
gain?
Yes, we have. I mean, I have solved a few questions on that. So,
Huh.
Huh.
So
So
can you
can you
explain me
explain me
how
how
to do
to do
that?
that?
Let's say
Let's
you
say you
have
have
some
some
XYZ
XYZ
circuit.
circuit.
You have a
You have a
certain V
certain
in
V
here,
in here,
and I
and
want
I
to
want to
find out
find
the
out the
gain here.
gain here.
yes. So we'll use two things first of all. So first we'll find out R Thevenin or R equivalent.
R
R
Thevenin.
Thevenin,
Looking
Fair
from
enough.
fair enough.
looking from the output node where we want the gain from
Okay.
that
Okay.
node
What would
inwards.
you
What would
do?
you do?
So, I mean, we'll apply a VTH and we'll short all the voltage sources and open all the current sources other than this VTest, and then we'll find out VTest by ITest, which will be R Thevenin.
I
I
test
test
and
and
call it
call it
R
R
Thevenin.
Thevenin.
Beautiful.
Beautiful.
Next.
Next.
Now what we'll do is we'll short the output, like make it to ground.
Okay.
Okay.
Apply the input with which respect to which we wanted to have gain. We'll
Fine.
apply
Fine.
that input,
Fine.
and
Fine.
then we'll find out this ISC in terms of V in,
Great.
Great.
and then this ISC by V in into R Thevenin will be our V out by V in, which is the gain.
So
So
finally,
finally,
you will
you will
put
put
ISC
ISC
In
and
and
parallel with
R
R7,
Thevenin,
Thevenin.
and
and
this
this
will be
will be
V
V
out.
out.
Yes.
Great.
Great.
Yes.
That's
That's
all
all
you
you
do,
do,
right?
right?
Awesome.
Yes.
Awesome.
So
So
this is
this is
called
called
short
short
circuit
circuit
Shorts.
analysis.
analysis.
Whatever you
Whatever you
want to
want to
call it.
call it.
I
I
call it
call it
short
short
circuit
circuit
analysis.
analysis.
This is
This is
especially
especially
useful when you
you
have
have
Uh,
voltage
voltage
controlled
controlled
current
VC,
current
sources in
sources.
the
VC,
circuit.
VCCS.
Okay.
Okay.
Yes.
It's
Yes.
It's
especially
especially
useful
useful
when
when
VCCS is
VCCS is
present in
present
the
in the
circuit.
circuit.
Great.
Great.
Yes.
Awesome.
Awesome.
Now,
Now,
because I
because I
know
know
everything is
everything
a
is a
current
current
source
source
inside,
inside,
I can use this method as well.
Yes.
Okay. So what do I do?
So first, let us find out R Thevenin or R out.
No. First is short circuit current.
Okay.
Mine
okay,
is
fine.
no,
So
I do
we,
whatever I want.
yes. I mean, we can do both of them. I mean, I mostly go for R out first and then I short circuit.
No. I want to do I short circuit first.
Okay. Fine.
Okay, I'm just kidding with you, man. Anyway, so let us start here. Okay. Again, let's say lambda is 0
Right.
for simplicity.
Hmm.
Okay. Now can you
Yes.
help me understand what is the what is the equivalent for this circuit?
So this will be R naught. What is this thing?
Open, right? Lambda is 0.
Oh, lambda is 0. Yes. If R naught is R naught will be infinite.
Correct?
Yes.
This is GM, and let's say a small signal this is Vx.
Okay. Right.
Okay,
So
in small
GM.
signal this will be Vd minus Vx.
Yes.
Fair enough?
Yes.
And this will be
GM V minus VD minus Vx.
fair enough?
Yes.
And some cloud is connected here. Fair enough?
Yes.
Now, can I apply KCL here?
You mean at the output?
No, in this current.
Okay. Yes.
GM times
VD minus Vx is equals to the other one.
GM times minus VD minus Vx. What is unknown? We don't know Vx.
Yeah, we don't know Vx.
Sorry. This is minus, right? I mean this current is in the opposite direction.
Yes.
So what does this equation force? So Vx is equal to
Minus GM. So GM VD minus. Oh, Vx is equals to 0. It's getting.
You see it, right?
Yes.
If RO is infinity, even though the circuit is imbalanced, it still forces this node to be differentially grounded.
Right.
If I give VD and minus VD, this is very important. I hope you see it. This Vx will only be 0 when I give VD and minus VD.
Yes.
Fair enough?
Yes.
So if I give VD and minus VD, this node will be what?
Grounded.
Virtual ground.
Virtual ground or AC ground.
Or AC ground, whatever you want to call it.
Right.
Now does our circuit analysis become easier?
Yes.
Okay. No, not so fast, Ravi. It's still not easy as you think it is. Oh, sorry, my bad.
We are not able to separate the top.
Exactly. So, I know that this fellow is virtual ground. So, this will be fair enough. I can erase all that, right? And I can give GM times VD minus VD, basically. Correct?
Yes.
And this will be
GM times minus VD.
Minus VD. Okay. Now this current directly goes to ground. So
Yes.
one component of I know one component of AEC is GM minus GMVD, correct?
Yes.
Now I'm trying to analyze what is the effect of this current on here. Correct?
Yes.
What do you think? This is GMVD. Flows here, correct?
Yes. If these is a current mirror, so if these two transistors are
So this will also be GMVD.
GMVD.
So what is the output current?
Oh, that
No.
is
I can
okay.
write it like this, right?
That 2 GMVD.
Perfect. So ISC is Fair
Fair
enough?
enough?
Yes.
Great.
Great.
So
So
we
we
found
found
one
one
half
half
of
of
problem is
problem is
solved.
solved.
Now the
Now the
other
other
half.
half.
What do
What
we
do we
do
do
for the
for the
other
other
half?
half?
So we ground VD and at both the inputs we'll ground it, and then so
Okay.
out at the output we'll apply V test.
Okay,
Okay,
sir.
sir.
1
1
minute.
minute.
Let me
Let me
draw.
draw.
Fair
Fair
enough?
enough?
Yes.
No,
No,
this
this
is.
is.
Vx will still be 0, right? In this case, I mean it doesn't change.
Oh,
Oh,
why?
why?
Have you
Have you
given a
given a
differential
differential
input?
input?
But I mean in that equation, let's say if we keep okay. Vx. But the previous equation that we took out, then only Vx, if we keep Vd plus is equals to Vd is equals to 0, that should be 0, right? Vx also.
No,
Yeah,
yeah,
but
but
there
there
is.
is.
See,
See,
the
the
small
small
circuit
circuit
equivalent
equivalent
is.
is.
This
This
small
small
circuit is
circuit is
equivalent
equivalent
is
is
valid
valid
when
when
you
you
give
give
small
small
signal
signal
input
input
here,
here,
correct?
correct?
No,
Yes.
No,
let's
let's
not
not
assume
assume
anything.
anything.
Let's
Let's
not
not
assume
assume
anything.
anything.
That's
That's
fair,
fair,
right?
right?
We are giving a small signal input at the
Here.
inputs.
Correct?
Correct?
Let's not
Let's not
assume
assume
anything.
anything.
I
I
derived
derived
Vx is
Vx is
0.
0.
Okay, fine.
Now you
Now you
need to
So
need to
case
derive
by
derive
case
Vx
Vx
is
basis.
is
0.
0.
Right.
Okay.
Okay.
Hmm.
Now,
No. Yeah.
see,
See,
back
back
then
then
Vx was
Vx was
0
0
because you
because
were
you were
giving a
giving a
differential
differential
signal
signal
across
across
the
the
two
two
branches.
branches.
Yes.
But
But
here
here
you are
you are
not.
not.
You have
You
to
have
be
to be
careful.
careful.
Correct?
Correct?
Okay. Hmm.
Huh. Okay,
Okay,
great.
great.
So
So
one, let's
let's
now
now
consider
consider
lambda
lambda
not
not
equal to
equal to
0,
0
because if
because if
lambda is
lambda is
equal to
equal to
0, you
0,
will
you will
get
get
infinite,
infinite,
correct?
correct?
Yeah.
Because
Because
this
this
current
current
won't
won't
flow
flow
up
up
or
or
nor
nor
flow
flow
down.
down.
Everything
Everything
is
is
constant.
constant.
Yes. I mean that.
I mean,
I
I
mean, I
test will
test
be
will be
0.
0.
It's
It's
very
very
boring.
boring.
Ravi,
Ravi,
do
do
you
you
agree
agree
that
that
if
if
lambda
lambda
is
is
0,
0,
I
I
test will
test
be
will be
0?
0?
Yes. In that case.
So
So
now
now
I'm
I'm
considering
considering
lambda is
lambda is
not
not
equal to
equal to
0.
0.
And
And
every
every
transistor will
transistor
have
will
its
have its
own
own
ROP,
ROP,
correct?
correct?
Yes. Just a small doubt in this. So if the transistor which is the right hand side one, just below I test one. So in that case, this I test. So if let's say Vx is not equals to 0, right? If you have some value of Vx, so in that case we have got a VGS. Even if lambda is equals to 0, then also the current should flow, right?
Correct.
Correct.
No. Sorry, I
Sorry, I
didn't
didn't
get you.
get you.
Come
Come
again.
again.
If
If
lambda is
lambda is
not,
not,
if
if
lambda
lambda
is
is
equal to
equal to
0,
0, what
what should
should
Yes.
happen?
happen?
So the on the right hand side, let's say if we consider that
Why
transistor,
Why
this
will this
so
current
current
flow?
flow?
so I'm saying because let's say if Vx is not equals to 0,
Oh,
Oh,
you are
you're
let
saying
saying
Vx is
Vx is
not
not
equal to
equal to
0.
0.
yes.
Okay.
Okay.
So
Fine,
Fine,
fair
fair
enough.
enough.
If
If
Vx is
Vx is
not
not
equal to
equal to
0,
0,
some
some
current
current
might
might
flow.
flow.
yes, that's what
Okay.
I meant.
How
How
will
will
this
this
V-test
V-test
affect
affect
this
this
Vx?
Vx?
That can
That
you
can you
tell
tell
me?
me?
So I test will be
When you
When you
don't know,
don't know,
what do
what
you
do you
do?
do?
You
You
do
do
a
a
put
put
a
a
small
small
circuit
circuit
equivalent,
equivalent,
correct?
correct?
yes.
So
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 there is
there is
some
some
cloud
cloud
here.
here.
Okay.
Okay.
This
This
is
is
Gm
Gm
times
times
Vx.
Vx.
I
I
mean,
mean,
sorry.
sorry.
Minus
Minus
Gm
Gm
Vx.
Vx.
yes.
This will
This
be
will be
minus
minus
Gm
Gm
Vx.
Vx.
This is
This is
Vx.
Vx.
Fair
Fair
enough?
enough?
Yes.
And you are
And you are
putting a
putting a
V
V
test
test
here.
here.
And you are
And you are
trying to
trying to
measure
measure
I
I
test.
test.
And lambda is, if
If
lambda is
lambda is
0, the
0, the
upper
upper
is
is
definitely
definitely
open,
open,
right?
right?
Yes.
Fair
Fair
enough?
enough?
So
So
if I
if I
test
test
has to
has to
flow,
flow,
it
it
has to
has to
flow
flow
like
like
this
this
only.
only. Fair enough, Ravi. Did I make any
Yes,
sense?
yes. So I'm just considering in this case on the left hand side also we have minus GMVX, which will force a current on the top, the current mirror as well, right?
Oh, okay. Let us. Okay, fair enough. Yeah. My bad. Sorry, Ravi. Yeah. Okay, great.
So in that case also the current should flow, I mean from the top side as well.
No, let us see. Can we put KCL here?
Yes, we can put.
What does it tell?
So it tells that I mean Vx is equals to 0.
Exactly. If lambda is in zero, Vx has to be zero.
Okay.
Fair enough.
Yes, got it.
No problems, right?
Yes, I mean yes, Vx is equals to 0. That change everything.
Yeah. If lambda is zero, Vx is zero.
Right.
Okay. No, that is why. If lambda is not equal to zero is when fun starts. Okay.
Yes.
When lambda is not equal to zero, what happens? We definitely know that a resistance is here, correct? ROP.
Yes.
Fair enough?
Right.
Looking down is RON.
Yes.
There is no argument there also, correct?
Yes.
No. Standing here, if I have to find looking in impedance, it is RON parallel whatever is here, correct?
Yes.
Now, what is the looking in impedance like this?
So that is R naught R naught N plus R naught P divided by 1 plus
Yeah. What? Why? So you want to find looking in impedance like this, correct?
Yes.
So what do you do? GMN Vx. Here you connect a Vx and try to find Ix.
Yes.
And here what is connected? Cooper.
That's a resistor basically.
1 by GMP.
Yes,
So
diode.
can you tell me what is Ix?
Ix will be Vx. That is
Sorry,
GM and Vx.
minus GM and Vx, right?
Yes, yes.
Gate is
0,
grounded.
0 man. Yes.
So Ix is GM and Vx, correct?
Yes, so when we didn't consider lambda is equals to 0, I mean lambda is not equals to 0, so ideally this should also have an input impedance. Sorry, an impedance, right? R naught.
Yeah, I didn't get you.
So transistor 1, which is on the left, if lambda is not equals to 0,
Okay.
then in this case we haven't assumed that R naught is present, right?
Fair enough.
But if lambda is not equals to 0, we have to take the presence of R naught as well.
Okay, fine. You consider R not like this. Fair enough.
Yeah, okay.
Even know what is Ix.
Ix will be now minus GM and Vx plus Vx by
Some complicated transfer function which has RO in it, correct?
Yes.
You can go ahead and do it. I won't discourage you, but I know the answer is approximately GMN and Vx because you are looking into the source of the transistor.
Yes, I mean approximately. Yeah, this is
Approximately, yeah. Fair enough?
Yes.
So what is 1 by GM parallel RON?
1 by GM parallel RON. Oh, okay. Yeah. So that is the resistance looking into from this node.
Which is approximately?
1 by GM.
1 by
Yeah, 1 by
GM
GMN.
parallel RON is approximately 1 by GMN.
1 by GMN. Yes.
Fair enough?
Yes.
So for this transistor, it looks like this. 1 by GMN is connected. For this, I rewritten this transistor.
Yes.
Fair
Fair
enough?
enough?
Yes.
Just 1 second.
Huh.
So
So
what is
what
the
is the
looking
looking
down
down
impedance
impedance
now?
now?
That would be R naught
GM, GMN?
GM GMN into 1 by GMN
Uh-huh.
approximately
Yeah.
Yeah.
Into
Into
into R naught
plus
N plus 1
1
by
by
1 by
GMN
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 plus
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 R naught.
fair
fair
enough?
enough?
Yes.
Approximately
Approximately
2
2
RON,
RON.
Yes. Yes.
correct?
Correct?
Yes.
So
So
looking
looking
down
down
impedance is
impedances
1
1
2
by
by
RON.
2
2
RON.
RON.
Yes.
Fair
Fair
enough?
enough?
So
So
if
Yes.
you
if you
give
give
V
V
test
test
here,
here,
what is
what
the
is the
current
current
that will
that will
flow
flow
here?
here?
V
V
test
test
by
by
2
2
RON.
RON.
Yes.
Correct?
Correct?
That
That
will
will
flow
flow
here
here
and
and
it
it
flows
flows
mostly
mostly
here.
here.
Correct?
Correct?
Because
Because
RON
RON
and
and
1 by
1 by
GMN,
GMN,
if it
if it
fights,
fights,
1 by
1 by
GMN will
GMN will
win.
win.
Correct?
Correct?
Yes.
And
And
that
that
flows
flows
up
up
like
like
this.
this.
Correct,
Right.
Correct,
Ravi?
Ravi?
Yes.
And it
And it
copies
copies
here.
here.
Yes.
So
So
totally,
totally,
what is
what is
I
eye
test?
test?
I
Eye
test
test
will
will
be
Twi
be
V
V
test by
test by
ROP
twice.
ROP
Yeah. Into 2.
plus,
plus,
no, no,
no,
no,
no, no,
ROP is
ROP is
this
this
fellow.
fellow.
But the same current is flowing on. Okay.
This
I
This
mean,
fellow's
it
fellow's
will
ROP.
be.
I'm
I'm
talking
talking
about the
about the
Upper ka
Upper ka
current.
current.
Yes, but you said when the current flows over here on the left
We'll
side
We'll
write
onto
write
the
that
that
top.
component
component
for.
for.
Okay,
Okay,
Okay.
I'll
I'll
Okay.
put
put
this
this
in
in
blue.
blue.
Okay.
Okay.
You
You
agree
agree
that
that
I
eye
test,
test,
when you
when you
give
give
V
V
test,
test,
ROP
ROP
may
may
some
some
current will
current will
go.
go.
Yes.
And that
And that
ROP is
ROP is
connected to
connected to
ground.
ground.
Yes.
Correct?
Correct?
Yes.
So I'm
So I'm
writing
writing
V
V
test by
test by
ROP
ROP
Right.
plus
plus
V
V
test by
test by
RON
RON
by
by
2
2
RON
RON
like
like
this.
this.
Correct?
Correct?
Yes.
Plus
Plus
V
V
test by
test by
2
2
RON,
RON,
which
which
goes
goes
like
like
this
this
because
because
of
of
the
the
current
current
mirror
mirror
effect.
effect.
Did I
Did I
confuse
confuse
you?
you?
So this was, I mean, I understood, but the only thing that's confusing is like there are two currents that are going. So um, the left-hand side current, which is mirroring on the right-hand side, which
Mhm.
is it just through the current mirror source? I mean, the dependent
Yes,
Yes,
sir.
sir.
current source.
You are
You are
exactly
exactly
right.
right.
This here you
Here you
see
see
there are
there are
two
two
branches,
branches,
correct?
correct?
Yes.
One through
One
the
through the
MOSFET,
MOSFET,
another
another
through
through
ROP.
ROP.
Okay. Okay.
The
The
branch,
branch,
this
this
current
current
is
is
this
this
guy.
guy.
V
V
test by
test by
R
R
to
to
RON.
RON.
Right. The current that is copying.
The
The
That is
current
the
that
current
is
that is
copying.
copying
copying
through the
through the
MOSFET.
Right.
MOSFET.
Okay. Okay.
The
The
Got it.
second
Yes.
second
current
current
upper
upper
is
is
ROP.
ROP.
Hmm.
The
The
third
third
current
current
niche
niche
is
is
R
R
test by
test by
2
2
RON.
RON.
Right.
So
So
effective
effective
impedance
impedance
is
is
ROP
ROP
parallel
parallel
RON.
RON.
Finally.
Finally.
Hmm.
But
But
it's
it's
okay
okay
if I
if I
dump,
dump,
if
if
I'm
I'm
at
at
first
first
cut,
cut,
if I
if I
look
look
at this
at this
circuit, I
circuit, I
will
will
say
say
what?
what?
The
The
resistance
resistance
is
is
ROP
ROP
parallel
parallel
RON.
RON.
Yes. Yes.
Correct?
Correct?
Because you
Because
will
you will
small
small
signal
signal
ground
ground
this.
this.
Yes.
You
You
get it,
get it,
right?
right?
Yes. Yes. Yes.
But
Exactly.
But
the
the
mechanism of
mechanism of
ROP
ROP
parallel
parallel
RON
RON
is
is
like
like
this.
this.
You
You
get it,
get it,
right?
right?
Hmm. Yes. Yes.
You
Okay.
might
I
have.
mean, that is the complete, you can say, like detailed version of this thing.
Exactly.
Exactly.
But
But
whatever I
whatever I
explained
explained
is
is
what is
what is
happening.
happening.
You
You
might
might
come to
come
the
to the
correct
correct
answer,
answer,
but
but
not
not
with the
with the
correct
correct
theory.
theory.
Fair
Fair
Yeah.
enough?
Yeah.
enough?
I mean, this is more insightful.
Yeah.
Yeah.
Fair
Fair
enough?
enough?
Yes.
So,
So,
okay.
okay.
Finally,
Finally,
what is
what
the
is the
small
small
signal
signal
gain
gain
now?
now?
So we
2
had
2
GMN
ISC
GMN
into
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 ROP
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 parallel
parallel
RON,
RON,
parallel. Right.
which
which
finally is
finally is
approximately
approximately
GMN into RO.
Fair enough.
Yes.
If everything is of approximately the same order. So we increase the N from GMR to GMRO, which is a very larger number when compared to a generic GMR. Fair enough?
Yes.
Great. For so much improvement, we had to spend an hour to explain it to you. I've spent days trying to design this, and I'm sure some researcher took months to come up with this circuit. Fair enough?
It is worth that.
Yeah, it is definitely worth it because you will extensively use this circuit.
Yeah, thank you for that.
Anyway, do you know hyper-W method to design? Have you designed circuits? Or only you only analyze circuits till now?
Only analyze till now. So, I mean, in future, I'll be designing, but as of now, just analyzing.
Great. No, I mean, there is no urgency as such, but if you want to start designing, you have to. Everyone starts from a 5-pack transistor, and there is something called hyper-W method from where you start designing your journey. Okay.
So, are we
There's
going
a
to do that in?
lecture from Nagendra Krishnapura on hyper-W method. I suggest you to see it.
Sure. Okay. Thank you.
No, okay. Finally, from all the stories, I've explained you a 5-pack transistor. Now, let us intuitively understand what is going on in the circuit. Okay. One last time, we will analyze. Do I have a fair copy of the circuit somewhere? No. Oh my God. Okay. I have to redraw. Now, if this is V1 and this is V2, I can always rewrite V1 and V2 as VCM plus VD and VCM minus VD. Do you agree?
Yes.
I can always do that. Yes. No?
Yes.
Great. Now, can you tell me what happens if VD keeps on increasing? What happens? If VD keeps on increasing, this okay. In other words, if this potential keeps on being yanked up and this potential keeps on being yanked down, what do you think will happen?
So, on the left-hand side, the conditions will be maintained, but the right one might fall out of saturation, and as well as
No. Stepwise. Okay. Let's say VD is 0. What happens to both these currents?
they'll be equal.
They'll be equal. Correct?
Yes.
Now, if I increase VD a little bit and reduce okay, if I increase this potential and reduce this potential, does this current increase or decrease?
The left one will increase and the right one will decrease.
Will reduce. And there is some tipping point where
so
and I keep doing this.
So from the right side, we'll have no current at some point.
Exactly. So if I look at the current in this branch, okay, if VD was 0, it would have been I0, correct?
Yes.
And it would, if I keep increasing VD, I0 will start increasing and saturate at
2I0.
2I0, correct?
Yes.
And ulta, if I keep reducing VD,
so it will decrease and go to 0.
it go to 0. Fair enough?
Yes.
And this current,
So yeah,
Will
it
2
was
do that,
initially
correct?
this. Yeah, exact opposite of what's happening on the
Fair
right.
enough. And
Yes.
what is the linear region?
So that is between this before the saturation occurs between 0 and this thing.
Fair enough.
Yes.
So
So
this
this
circuit can
circuit can
also be
also be
used
used
as
as
a,
a,
if
if
the
the
gain is
gain is
high
high
enough.
enough.
Yeah, I've
I've
zoomed
zoomed
in,
in,
right?
right?
I've
I've
zoomed in
zoomed
a
in a
little
little
bit.
bit.
I've
I've
zoomed in
zoomed
a
in a
lot
lot
actually.
actually.
You
You
get
get
it,
it
right?
right?
I mean the characteristics, yes, and how
Huh.
linear region. Yes.
Huh.
No,
No, no.
linear
Linear
region
region
is
is
if
if
VD is
VD is
increased
increased
and
and
reduced a
reduced a
little
little
bit,
bit,
the
the
current
current
will
will
move,
move,
right?
right?
Yes. Yes.
And
And
that
that
is a
is a
small
small
signal.
signal.
And
And
it
Yes.
it
won't be
won't be
like
Exactly.
like
this.
this.
It'll be
It'll be
something
something
like
like
this
this
curvature.
curvature. It'll
Some curvature. Okay. Yeah.
And I
And I
will
will
linearize
linearize
it.
it.
Okay.
Fair
Fair
enough.
enough.
Hmm.
So if
So
the
if the
gain is
gain is
high
high
enough, you
enough, you
can
can
use
use
this
this
as
as
a
a
comparator,
comparator,
correct?
correct?
Uh, oh yes.
You
You
can
can
compare
Right.
two
compare
Right.
two
voltages,
voltages,
correct?
correct?
Yes.
Huh.
So
You
You get
get
it,
it
right?
right?
yes, basically, if the gain is very high, then I mean a small change even in the signal. I mean on
Huh.
both the sides
Huh.
Huh.
would lead to a very like either saturation or zero, something like that.
Perfect.
Perfect.
You
You
get it,
get it
right?
right?
Yes. Okay.
So
So
this
this
circuit can
circuit can
also be
also be
used as
used
a
as a
comparator in
comparator in
open
open
loop.
loop.
Hmm.
Okay?
Okay?
Now,
Now,
Yes.
the
the
assignment I
assignment I
give to
give to
you
you
is
is
find
find
out
out
what is
what is
this
this
tipping
tipping
point
point
of
of
VD.
VD.
What
What
is
is
the
the
tipping
tipping
point
point
of
of
VD
VD
to
to
ensure
ensure
that
that
the
the
whole
whole
2 I
2 I
naught
naught
current
current
flows
flows
through
through
one
one
branch.
branch.
Okay.
Fair
Fair
enough?
enough?
And this
And
is
this
a
is a
large
large
signal
signal
phenomenon.
phenomenon.
I
Yes.
mean,
I
you
mean,
have
you
to
have
do
to do
dot
dot
DC
DC
analysis, in
analysis, in
other
other
words,
words,
to
to
find
find
this
this
out.
out.
Hmm.
Fair
Fair
enough?
enough?
Yes.
Okay.
Okay.
This is
This is
your
your
assignment
assignment
for
for
today.
today.
Okay.
I would
I
have
would
done
have
it
done it
myself,
myself,
but I'm
but I'm
running out
running
of
out of
time
time
because I
because I
have to
have to
teach you
teach you
something a
something a
little
little
bit
bit
more
more
interesting. Do
interesting.
you
Do you
have
have
four
four
more
more
minutes,
minutes,
five more
five more
minutes?
minutes?
Yes. Yes. Definitely.
Okay,
Okay,
great.
great.
So,
So,
let
let
us
us
retrace
retrace
our
our
steps
steps
and
and
uh,
where
understand the
understand the
fully
fully
differential
differential
circuit.
circuit.
Okay.
Okay.
Right.
My
My
bad.
bad.
VD
VD
minus
minus
VD
VD
I
I
naught.
naught.
I
I
mean
mean
2 I
2 I
naught,
naught,
whatever.
whatever. Mm.
Okay.
Okay.
So
So
what
what
is
is
the
the
gain
gain
here?
here?
Small
Small
signal
signal
gain.
gain.
2 GM into
I
this
mean
I mean
RD.
GMRO,
GMRO,
right?
Um,
right?
yeah.
Okay.
GMR
Okay.
not.
I
I
mean,
mean,
what I
what I
mean to
mean
say
to say
is
is
this
this
fellow
fellow
will
will
be
be
minus
minus
GMVD.
GMVD.
This
This
fellow
fellow
will be
will be
GMVD.
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 So the
So the
differential
differential
voltage is
voltage is
2
2
GMVD.
GMVD.
I
I
mean
mean
GMRO
GMRO
VD.
VD,
Sorry.
sorry.
GMR not VD.
And
And
this
this
will be
will be
GMRO
GMRO
VD.
VD,
Correct?
correct?
So the
So the
Yes.
differential
differential
output
output
voltage is
voltage is
GMRO
GMRO
VD.
VD,
Differential
differential
input
input
voltage
voltage
is
is
2
2
VD.
VD.
So the
So the
gain is
gain is
GMRO.
GMRO,
Correct?
correct?
Yes.
No,
No,
I
I
mean,
mean,
to be
to be
honest,
honest,
GMRO by
GMRO by
2
2
because
because
RO
RO
of
of
bottom
bottom
fellow
fellow
and
and
RO of
RO of
top
top
fellow
fellow
will
will
fight.
fight,
Correct?
correct?
Oi,
Top and
okay.
Okay.
I
I
think
think
I
I
rushed a
rushed a
little
little
bit.
bit.
So,
So,
why did
why
you
did you
say the
say the
gain is
gain is
GMRO
GMRO
VD?
VD?
We do
We do
half
half
circuit
circuit
analysis,
analysis,
correct?
correct?
yes.
So,
So,
what is
what
the
is the
half
half
circuit
circuit
analysis?
analysis?
The
The
Ooper is
Ooper is
RO,
RO,
ROP,
ROP,
this
this
fellow,
fellow,
because
because
this is
this is
Yes.
grounded
grounded
That.
in the
in the
line of
line of
symmetry.
Yes.
symmetry.
Okay,
Okay,
Ooper is
Ooper is
ROP,
ROP,
Niche
Nietzsche
is
is
what?
what?
Oh, that would be 2 I naught. So that would be I naught. So that would be RON, let's say.
RON,
Yes.
and you
and
will
you will
have
have
a
a
GM
GM
feeding
feeding
in,
in,
GM
GM
VD
VD
going
going
in.
in.
So the
So the
gain
gain
is
is
GM
GM
ROP
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 parallel
parallel
RON
RON
ON.
into
into
VD,
VD,
VD.
which is
which is
approximately
approximately
GM
GM
RO
RO
by
by
2
2
ROP
into
into
VD.
VD.
2 divided.
Fair
Fair
enough?
enough?
Yes.
Now,
Now,
what
what
is
is
this?
this?
Why
Why
is the
is the
gain
gain
reducing?
reducing?
Because
Because
of
of
these
these
pesky?
pesky?
Why is
Why
the
is the
gain
gain
reducing
reducing
here?
here?
Because of these coming into parallel, the
Because
R.
Because
of
of
these
these
pesky
pesky
resistor
resistor
coming
coming
into
into
parallel,
parallel,
correct?
correct?
Yes.
Can I
Can I
somehow
somehow
eliminate
eliminate
this?
this?
This is
This is
V
V
out,
out,
correct?
correct?
Yes.
And
And
what is
what
this
is this
current?
current?
GMBD, which the top current.
This
This
current
current
here.
here.
Yeah.
In
Yeah.
In
small
That
small
is
signal,
signal,
I'm
I'm
writing
GMBD.
writing
small
small
signal.
signal.
VO
VO
by
by
RO by
V
2,
out
correct?
by R naught by 2. Yes. Okay.
Correct?
correct?
Yes.
Now,
Now,
if
if
I
I
somehow
somehow
magically
magically
add
add
this
this
V
V
out
out
RO
RO
by
by
2
2
current,
current,
somehow
somehow
magically
magically
add
add
GM
GM
RO,
RO,
I
I
mean
mean
RO by
RO by
2
2
current,
current,
then
then
you
you
see
see
that the
that the
gain
gain
becomes
becomes
infinity,
infinity,
correct?
correct?
VM by R naught by 2. So GMVD.
GMVD
GMVD
will
will
go,
go,
I
I
mean, the
mean, the
gain will
gain
be
will be
infinity.
infinity.
So if we are adding this current, so we are having R naught.
Okay. Wait,
Yeah.
yeah.
So
So
let
let
us
us
add
add
some
some
current,
current,
some
some
GM,
GM,
GM
GM
extra.
extra.
I'll
I'll
call it
call it
GM
GM
extra
extra
into
into
V
V
out.
out.
Right.
Let us
Let
say
us say
I'm
I'm
adding
adding
GM
GM
extra
extra
into
into
V
V
out
out
current.
current.
Some
Some
current
current
magically I'm
magically I'm
adding.
adding.
Hmm.
Okay.
Okay.
So
So
can you
can you
tell me
tell me
what
what
V
V
out
out
is
is
now?
now?
I
I
mean, it
mean,
is
it is
just
just
GMVD
GMVD
plus
plus
V
V
out
out
GMVD
RO
plus
RO
by
by
2
2
minus
minus
GME
GME
V
V
out
out
equal to
equal to
0,
0,
correct?
correct?
yes KCL.
KCL,
KCL,
simple
simple
KCL.
KCL.
Yes.
So
So
what is
what is
V
V
out?
out?
V
V
out
out
by
by
VD.
VD.
V out by VD would be GM upon R naught by 2.
Yeah,
Yeah,
I
wait. I
don't
don't
think
think
it's
it's
that
that
easy.
easy.
Let
Let
us
us
GMVD
GMVD
equal
equal
to
to
GME
GME
V
V
out
out
minus
minus
V
V
out
out
RO
RO
by
by
2,
2,
correct?
correct?
Yes.
So
So
V
V
out,
out,
I'll
I'll
go to
go
the
to the
next
next
page.
page.
I
I
mean, do
mean, do
you
you
understand my
understand my
handwriting when
handwriting
I
when I
write
write
fast?
fast?
Yes.
Okay.
Okay.
So
So
GMVD
GMVD
equal
equal
to
to
V
V
out
out
into
into
minus
minus
RO
RO
by
by
2
2
plus
plus
GME.
GME.
I'll
I'll
write it
write it
like
like
this.
this.
So
So
what is
what is
V
V
out by
out by
VD?
VD?
GM
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 by
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 minus
minus
RO by
RO by
2
2.
2
plus
plus
GME.
GME.
Hmm.
Do
Do
you
you
agree?
agree?
Yes.
No.
No. If
If magically
magically
I
I
choose
choose
GME
GME
equal to
equal to
RO
RO
by
by
2,
2,
Right. So yeah,
then
it's
then gain
gain
infinite.
becomes
becomes
Infinite.
infinite,
infinite,
correct?
correct?
Yes.
Can you
Can you
help
help
me
me
generate
generate
RO
RO
by
by
GME?
GME? I mean,
So
so
what do
what
I
do I
want?
want?
I
I
want
want
GME
GME
into
into
V
V
out
out
current
current
being
being
pushed
pushed
into
into
V
V
out
out
node.
node.
Can you
Can you
help me
help me
generate this
generate this
current?
current?
GME into V out.
Okay.
One
1
minute,
minute,
yeah.
yeah.
This
This
is
is
V
V
out,
out,
correct?
correct?
Yes.
And
And
this
this
will be
will be
minus
minus
V
V
out,
out,
Hmm.
correct?
correct?
Yes.
Can you
Can you
help
help
me
me
generate
generate
GME
GME
V
V
out?
out?
If we apply it like V out as an input to the gate of a transistor.
Okay.
Great.
Great.
So
So
you
you
want to
want to
apply,
apply,
you
you
want to
want to
take
take
a
a
NMOS or
NMOS
a
or a
PMOS?
PMOS?
I mean, so NMOS because we'll VGS. Let's say we put it to 0. S.
S you okay, you want to take V, okay. How do you want to connect? You want to take this V out?
And connect it to the gate of a NMOS.
Okay, I will connect, okay, I'll write it here, okay, I don't have space. I'll connect it to the gate of NMOS. Now?
So the current flowing through it will be GM into V out. GM.
Okay, GM into V out, then?
Yeah, okay. Now GM has to be equals to R by
No,
T.
wait, yeah, you have to push this where?
Oh, so we have to push that into the R0, okay, into the circuit again.
See, here, concentrate, okay? This is RO. Let us say there is only RO, not RO. Okay, we'll have RO by 2 here. Okay, and this is V out.
Yes.
Where do you push this current? Look, it has to go in V out, inside V out.
Yes, I mean inside of the V out, right? We'll push it in there.
Fair enough?
Yes.
So if you do this and choose, okay, here I can connect this to supply, correct? I mean VDD.
Yes. Yes, but then again, this V out and V out both are, I mean, same VGS will be 0.
Perfect. You are awesome. So NMOS won't work.
Right, okay.
Do you get it?
Yes.
So what do I do? Can I choose a PMOS?
Yes, we can try with PMOS.
Okay, we'll try with the PMOS. Now what do I do?
So VSG can be
My bad. What do I do?
so if we apply this to the input of this thing,
V out.
let's say that's V out.
Same. You say I connect V out.
Yes.
So what happens? What is this current?
So that is GM times VD minus.
Yeah, V out, a small signal. This is ground.
Oh, small signal analysis. Yeah, okay. Yes. In small signal, it is GM. Okay.
Do you like this? I mean, it is going away from ground.
Away from ground.
I mean, going towards ground.
Yes.
V out is going towards ground, but you need into the node.
So that is also not.
But what if I use minus V out here?
So then it will flow opposite. Yeah, then it will go into the
down, correct?
Yes.
And where do I have this minus V out?
On the other terminal.
On the other terminal, correct?
Yes.
So if I magically choose the GM of the PMOS, so this is possible, right?
Yes, we can.
So to rewrite the circuit, so here is a circuit for you, and let me cleanly write it. So I can take this minus V out, correct?
Yes.
And push this guy in. Fair enough?
Yes.
And do the same thing here. I mean, I have to do the same thing here, right?
Okay. Yes.
And I sorry, my bad. What
This will be.
My bad. Just 1 second. Why am I? My drawing skills are not really great here. But I hope you get the point.
Yes.
So if you do this, I can increase gain. Correct?
Yes.
You understood the circuit, right?
Yes, yes.
Awesome.
So,
But
I
I
have to
have to
be
be
careful
careful
here.
here.
And
And
okay.
okay,
And
and
what
what
is
is
this
this
component
component
here?
here?
If
If
this
this
is
is
V
V
out,
out,
a
a
resistor
resistor
takes
takes
current
current
and
and
pushes
pushes
it to
it to
ground,
ground,
correct?
correct?
I
I
mean,
mean,
look,
look,
if
if
this is
this is
V
V
out,
out,
current is
current is
going
going
down,
down,
RO
RO
by
by
2
2
Mane,
Mane,
correct?
correct?
Hmm.
But
Yes.
But
what is
what is
this
this
guy
guy
doing?
doing?
It
It
is
is
from
from
ground, it
ground,
is
it is
pushing
pushing
into
into
the
the
node.
node.
Pushing.
So
So
this is
this is
a
a
negative
negative
resistance,
resistance,
correct?
correct?
Oh, okay. Yes.
Fair
Fair
enough.
enough.
Hmm.
So if
So
you
if
have
you
a
have a
negative
negative
resistance,
resistance,
you
you
can
can
increase the
increase the
gain.
gain.
Fair
Fair
enough?
enough?
That's the crux of it.
Ha.
Ha.
I mean,
I
you
mean,
get
you
the
get the
point, right?
point, right?
Yes, yes.
Ha.
Ha.
But
But
what is
what
the
is the
danger?
danger?
Okay,
Okay,
there is
there is
definitely
definitely
some
some
gocha
gocha
here. I
here. I
mean, you
mean, you
can't
can't
make
make
all
all
circuits
circuits
can't
can't
have
have
infinite
infinite
gain,
gain,
correct?
correct?
Yes.
All
All
differential
differential
pairs
pairs
could
could
have
have
been
been
attached
attached
with
with
this
this
contraption,
contraption,
and
and
the
the
world
world
would
would
have
have
had
had
infinite
infinite
gain,
gain,
right?
right?
Yes. I mean,
But
But
there is
there is
some
some
catch
catch
here.
here.
What do you
What do you
think the
think the
catch
catch
is?
is?
feedback.
Something
Something
related to
related to
that.
that.
Can you
Can
be
you be
more
more
specific?
specific?
See,
See,
okay,
okay,
how do
how
you
do you
use a
use a
circuit,
circuit,
right?
right?
You
You
assume
assume
some
some
negative
negative
feedback,
feedback,
correct?
correct?
Yes.
The
The
gain
gain
is
is
very
very
high
high
and
and
negative.
negative.
The
The
gain
gain
from
from
this
this
point to
point to
this
this
point
point
is
is
negative
negative
and
and
high,
high,
Yes.
correct?
correct?
Look,
Look,
if
if
GME
GME
was
was
zero,
zero,
in the
in the
sense if
sense
you
if you
didn't
didn't
have
have
any
any
contraption, the
contraption, the
gain
gain
would
would
have
have
been
been
minus
minus
GM
GM
RO
RO
by
by
2.
2.
You
You
agree,
agree,
Ravi?
Ravi?
Yes.
The
The
gain is
gain is
negative.
negative.
Yes.
And you
And
In
you
keep
that
keep
on
case.
on
increasing
increasing
GME,
GME,
and
and
it
it
becomes
becomes
infinite at
infinite at
one
one
point.
point.
Hmm.
But
But
then,
then,
if you
if you
increase
increase
even a
even a
little
little
bit,
bit,
it
it
becomes
becomes
positive.
positive.
Ravi, am
Ravi,
I
am I
confusing
confusing
you?
you?
Yes, the last part one. I mean,
Okay,
Okay,
let's say
let's say
GME
GME
was
was
zero
zero
here.
here.
right.
The
The
gain
gain
is
is
So,
some
some
number,
number
but
but
negative.
negative.
Do
Do
you
you
agree?
agree?
yes.
No.
No,
Let's
let's
keep
keep
increasing
increasing
GME
GME
from
from
zero.
zero.
Okay, okay. At some point,
It
yeah, it
It
would
becomes a
becomes a
become
high
high
negative
negative
positive.
number,
number,
high
high
negative
negative
number,
number,
high
high
negative
negative
number.
number.
But
But
then
then
at the
at the
tipping
tipping
point,
point,
it
it
becomes
becomes
a
a
high
high
positive
positive
number.
number.
Yes. I mean, from suddenly from negative,
Negative
at
high,
Negative
that
high,
point, it will
it
go
it
becomes
to
becomes
positive high.
positive high.
positive high. Yes.
And this
And this
circuit
circuit
will
will
completely
completely
fail.
fail.
Would it be like because of the stability factor or something?
No,
No,
no.
no,
It is
it
the
is the
choice of
choice of
GME,
GME,
na?
na?
Yes, I mean, like from negative gain to we are having a positive gain.
Ha,
So what is,
so
What is
what
this
is this
circuit?
circuit?
This
This
circuit
circuit
is,
is,
what is
what
it
is it
doing? It's
doing?
a
It's a
positive
positive
feedback
feedback
circuit.
circuit.
uh,
Okay.
Okay,
yeah, so it is increase.
It is
it is
increasing the
increasing the
gain
gain
by
by
pushing a
pushing a
negative
negative
component.
component.
Mm,
I,
yes.
I
I
don't know
don't know
how
how
to
to
convince
convince
you
you,
here.
yaar.
Okay,
Okay,
try,
try,
sit
sit
and
and
think
think
about
about
this
the
circuit.
circuit.
You will
You will
see
see
that
that
Right.
you are
you are
increasing
increasing
gain by
gain by
adding a
adding a
negative
negative
component.
component.
That
That
means
means
positive
positive
Yes,
feedback.
feedback.
yes. That I understood. Like, I mean, so we are taking it from negative high at the tipping point, from a very negative high to a very positive high, right? If we change slightly.
Correct.
Correct.
Uh, so that means it's switching, like at that point, it's like completely the opposite of what the gain we had in a
Correct.
different
Correct.
direction.
Correct.
Correct.
Uh, so, uh, I mean, I'm just thinking of the implication of that. Like, what would it implicate?
Exactly.
Exactly.
Na.
Na.
See,
See,
if
if
you
you
wanted a
wanted a
very
very
high
high
negative
negative
number,
number,
Hmm.
but
but
thoda
thoda
idhar
idhar
udhar
udhar
ho
ho
gaya
gaya
and
and
the
the
high
high
negative
negative
number
number
became
became
high
high
positive
positive
number.
number.
Okay, so
and your
your
circuit
circuit
will
will
fail.
fail.
Right.
So
Um,
you can't
You can't
micro
micro
optimize
optimize
this. You
this. You
can
can
use
use
this
this
tool
tool
for a
for a
little
little
bit.
bit.
mhm.
See,
See,
okay.
okay.
Why
Why
am I
am I
telling you
telling you
all
all
this?
this?
I'm
I'm
telling you
telling
all
you all
this
this
because
because
if
if
in a
in a
fully
fully
differential
differential
system,
system,
there is
there
a
is a
contraption
contraption
for you
for
to
you to
increase
increase
gain in
gain
a
in a
single
single
stage
stage
system.
system.
Right.
Okay,
Okay,
this
this
circuit is
circuit is
handy
handy
if you
if you
use
use
it
it
intelligently.
intelligently.
Right.
Across,
Across,
you
you
have to
have to
ensure
ensure
that
that
across
across
PVT,
PVT,
GME
GME
is
is
always
always
less
less
than
than
RO
RO
by
by
2
2
of
of
this
this
fellow
fellow
and
and
this
this
fellow.
fellow.
What is PVT?
Process
Process
voltage and
voltage and
temperature.
temperature
Across
across
all the
all the
corners.
corners.
Oh,
I
I
mean, a
mean, a
chip,
chip,
right?
right?
It
It
can
can
be
be
made
made
in
in
multiple
multiple
corners.
corners.
hmm.
So
So
across,
across, you
when you
when you
simulate, when
simulate,
you
when you
design,
design,
right?
right?
You
You
should
should
ensure
ensure
that
that
GME is
GME is
less
less
than
than
RO
RO
by
by
2
2
for
for
all
all
available
available
corners.
corners.
Okay.
This is
This
So
is
that is
gain.
a
gain.
This is
This is
also
also
called
called
gain
gain
boosting
boosting
transistors.
transistors.
Fair
Fair
enough?
enough?
right.
But
But
you
you
have to
have
be
to be
careful
careful
when you
when you
use
use
such
such
circuits.
circuits.
Uh, so the design, like GME and this R naught by 2,
Mhm.
if you are using this circuit, then is it like dependent on the design or is it dependent on the process?
Oh,
Oh,
that's what
that's what
you
you
design
design
at.
at,
You
you
have to
have to
ensure
ensure
that your
that your
design is
design is
stable
stable
across
across
process
process
voltage and
voltage and
temperature.
temperature.
Okay.
I mean,
And
see,
see,
what is
what is
designing
designing
here?
here?
It
It
is
is
choosing
choosing
I
I
for
for
every
every
transistor
transistor
and
and
W
W
for
for
every
every
transistor.
transistor.
Yes.
Correct?
Correct?
Yes.
So
So
you
you
have to
have to
choose
choose
I
I
and
and
W
W
such
such
that
that
for
for
every
every
transistor
transistor
such
such
that
that
across
across
PVT,
PVT,
your
your
GME is
GME is
less
less
than
than
RO
RO
by
by
2.
2.
Okay.
I
I
mean,
mean,
okay,
okay,
I
I
don't
don't
expect you
expect
to
you to
understand
understand
the
the
entire
entire
thing
thing
first
first
cut,
cut,
but at
but at
least did
least
you
did you
get the
get the
picture
picture
as to
as to
what I'm
what I'm
trying to
trying to
Uh,
do?
do?
yes, that is clear.
Huh.
Huh.
So
So
you
you
go
go
sit
sit
and
and
think
think
about
about
this
the
circuit
circuit
because I
because
have
I have
thought
thought
about
about
the
the
circuit
circuit
for
for
hours
hours
together,
together.
and I
And I
don't
don't
expect you
expect
to
you to
get it
get it
first
first
cut.
cut,
Okay.
okay?
If
If
you
Hmm.
you
do,
do,
you're
you're
really
really
awesome.
awesome.
But
Uh,
But
this is
this is
called
called
boosting
boosting
gain
gain
using
using
negative
negative
resistors.
resistors.
hmm.
Okay.
Okay?
Yes. So this negative resistor concept is like kind of like to always boost the gain in such scenarios.
Yeah,
Yeah,
mostly it
mostly
is
it is
used,
used.
and
And
in oscillators
oscillators
as
as
well.
well.
Okay,
Okay,
let
let
me
me
tell
tell
you
you
quickly.
quickly.
You
You
have an
have an
LC
LC
tank
tank
oscillator,
oscillator,
correct?
correct?
Yes.
And
And
with
with
this,
this,
you
you
will
will
always
always
have a
have a
parasitic
parasitic
resistance in
resistance in
parallel.
parallel.
Right.
So
So
what we
what we
do
do
is
is
we
we
add a
add a
negative
negative
parasitic
parasitic
resistor
resistor
and
and
make
make
this
this
infinite.
infinite.
Okay.
And
And
this
this
is
is
implemented
implemented
like
like
this.
this.
Hmm.
I
I
mean,
mean,
at
at
least
least
basic, did
basic,
you
did you
understand?
understand?
Yes.
So
So
it,
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 it's
it's
not
not
a
a
2 minute
two-minute
discussion,
discussion,
Ravi.
Ravi.
If you
If you
want to
want to
make an
make an
oscillator,
oscillator,
it
it
is
is
a
a
whole
whole
different
different,
course
course
only.
only.
Okay,
Okay,
but
but
Okay.
some
some
applications of
applications
a
of a
negative
negative
resistor
resistor
are
are
this.
this.
I
I
mean,
mean,
you
you
got the
got the
gist,
gist,
right?
right?
I
I
mean, there
mean,
is
there
an
is an
R
Yes.
R
Yes.
para
para
which
which
will,
will,
I
I
mean,
mean,
which
which
will
will
attenuate. I
attenuate. I
mean,
mean,
you
you
get it
get it
right
right
if
if you
if you
if you
push an
push an
impulse
impulse
current
current
into a
into a
tank,
tank,
it will
it will
oscillate,
oscillate.
correct?
Correct?
Yes.
But
But
what is
what is
detrimental? If
detrimental?
you
If you
have
have
any
any
parasitic
parasitic
resistor,
resistor,
the
the
oscillations will
oscillations will
die
die
down,
down.
correct?
Correct?
Yeah. Dampening effect. Yes.
Huh.
Huh.
So
So
to
to
prevent
prevent
damping,
damping,
we
we
put
put
minus
minus
R
R
par
par
resistor
resistor
here
here
through
through
active
active
circuit
circuit
obviously,
obviously,
and
and
ensure
ensure
that
that
R
R
par
par
is
is
infinite.
infinite.
This
This
R
R
par
par
R
R
par
par
ka
ka
effect
effect
goes
goes
away.
away.
Okay.
You
So that we
understand?
have undamped, yeah, undamped
Undamped,
oscillation.
crazy, stable oscillations.
Right.
Fair enough?
Yes.
Okay.
Okay.
Do you
Do
know
you know
other
other
kinds of
kinds of
phase
phase
shift
shift
oscillators?
oscillators?
Blah,
Blah
blah,
blah
blah,
blah
blah,
blah
blah.
blah.
One of the
One of the
I
assignment
think,
assignment
questions
questions
has
has
it. I
it. I
think you
think you
should
should
solve
solve
it.
it.
okay.
Do you
Do
know
you know
Barkhausen's
Barkhausen's
Oh,
criterion?
criterion?
yes. I recently learned it.
Yeah.
Yeah.
So
So
if
if
you
you
there is
there is
this
this
oscillator
oscillator
in the
in the
assignment
assignment
as
as
well.
well.
Cool
Cool
circuit. You
circuit. You
should
I,
should
analyze it.
analyze it.
yes, I did that. Yeah.
I
I
mean,
mean,
two
two
A into beta
integrators
is
integrators
equals to
in
1.
yeah,
yeah,
two
two
integrators in
integrators in
feedback
feedback
loop
loop
and
and
connecting
connecting
like
like
this.
this.
Yes.
I
I
mean,
mean,
this
this
gives a
gives a
180
180
degree
degree
phase
phase
shift.
shift.
This
This
gives a
gives a
180
180
degree
degree
phase
phase
shift,
shift,
and
and the
entire
entire
thing
thing
gives
gives
you
you
360
360
degree
degree
phase
phase
shift,
shift,
and
and
the
the
oscillations will
oscillations will
sustain.
sustain.
Yes. And the other is like the gain has to be equals to 1.
One,
One,
yeah,
yeah,
Total.
yeah.
yeah.
Okay.
At
At
one by, if
if
the
the
integrator is
integrator is
1 by
1 by
s,
s,
Right.
the
the
integrator
integrator
is
is
1 by
1 by
s,
s,
right?
right?
Yes.
So
So
at
at
UGB, the
UGB, the
gain will
gain
be
will be
1
1
and the
and the
phase will
phase
be
will be
180
180
degrees.
degrees.
And it
And
will
it'll
oscillate
oscillate
at
at
this
this
frequency.
frequency.
Anyway,
Anyway,
you
you
should,
should,
these
these
kinds
kinds
of
of
oscillators are
oscillators are
called
called
phase
phase
shift
shift
oscillators
oscillators
because
because
integrators are
integrators are
used to
used to
shift the
shift the
phase
phase
by
by
90
90
degrees.
degrees.
Am
Am
I
I
overwhelming
overwhelming
you
you
with
with
information?
information?
No, it's fine.
So
So
read
read
about it
about it
as
as
well.
well.
It's
It's
interesting
interesting
read
read if you want,
if you
if
are
you are
interested in
interested in
oscillator
oscillator
design.
design.
Sure.
Fair
Fair
enough.
enough.
Okay,
Okay,
I
I
think I
think I
Yes.
held
held
you
you
on
on
for
for
way
way
too
too
long,
long,
and
and
I
I
also
also
sat
sat
for
for
way
way
too
too
long.
long.
I
I
had
had
a
a
fun
fun
class
class teaching
teaching you
you
this
this
time.
time.
Let's
Let's
meet
meet
next
next
week.
week.
Sure. Yeah. Thank you so much for this.
Okay.
Okay.
Great
Great
man.
man.
No, I
No, I
should
should
thank you.
thank you.
Anyway,
Anyway,
thank
thank
you.
you.
Bye
Bye
bye.
bye.
Yeah. Thank you. Bye.